Good morning. Today's Monday and Saturday's Christmas, so I feel like I've got a lot to get done this week. I'm currently working on the design of a single-seat ultralight, and I wanted to discuss through some of the things that I'm seeing and dealing with as I go through the process of designing the plane. I've got it on the screen of the computer here, and I'm doing all of my work in SketchUp. Why SketchUp? I know it. I learned it a long time ago. It's, in my opinion, super easy to use, and actually it's pretty darn good for doing frame modeling of structures. It's not the best for rounded surfaces, but there's some tricks and compromises that can get you through on that. However, when it comes to the heavy-duty stuff, I like to switch over into Fusion 360, or for that matter, SolidWorks. But that's another story. Anyway, working on the design of the airplane here. Single seat, and everything that you see here structure-wise is made out of honeycomb aluminum. Well, the first question that you might ask is why honeycomb aluminum sounds exotic, sounds expensive, versus simpler versions of metal or even wood. And that's a great question. One of my Patreon was asking something about the comparison of honeycomb to wood. So entirely valid question. And the answer to it is really, I'm not sure I know the answer to it. I'm working on it. I do have a fair bit of half-inch honeycomb on hand, enough to build quite a few airplanes. So that's one thing that's driving me, that I have available inventory of the honeycomb. The second thing is that it's somewhat, if you can build with honeycomb the way that I'm doing it, you can probably build it using angles and tubes as well. Not saying that that's the direction that I would want to go, but that can be done. The third thing is that if you can build it like this with a frame with honeycomb, you can certainly build the same structure with plywood frames and formers, and that might provide an option for down the road as well. We'll just have to see. A few other things. The embarrassing thing here is I do not have a model for the engine. I've rested a 38 horsepower Polini 303 water-cooled engine on the front of this thing, which is just which I stole out of a 3View. And then I downloaded an STL prop model, which is not the greatest model as well, but it's in the right position. It certainly shows where things are supposed to be. And then I I stole from my own CAD the landing gear. This is a landing gear out of a Chipper 2, and changed their positioning just a bit. I'll have to update that down the road with a lower cost non-machine version of the landing gear, and also lighter, in order to make this be an ultralight. Some of the design features that I'm working on here include well, Part 103 compliance. Part 103, I've been working with that for since 2008. That makes me not quite an oldster in that field, but I've been working with it now for about 13 years. And we can check off most of the, we can check off all of the things in Part 103 that are critical. Clearly this is a single-seat airplane. We'll put a 5-gallon fuel tank in it, and I'm designing it so that it will have a stall speed of 28 miles per hour, hopefully a little bit less than 28 miles per hour, because I'm a huge fan of STOL, short takeoff and landing, and the lower that I can get the stall speed, the better I can get this thing off the ground and landed as well. So those are hand-in-hand goals. But continuing the Part 103 stuff, top speed of 63 miles per hour, which can be limited in many ways, including prop pitch, power, RPM, drag, and so forth. And an all-up weight of 254 pounds or less. Now that's one that I know that I can meet or beat because of the design tricks that I've learned over the year. That's not really a great way to explain it, but design tricks. Well, for instance, back in the olden days of UltraCub, I got mad because someone said you can't build this and be Part 103. It's like, yes, you can. And we built one, and it came in at I think it was 223 pounds. So it can be done, and it's, in fact, now it's pretty easily done as we've gotten better with structures and materials. There's lots of people that have done legal ultralights. My claim here is that I'm giving you a enclosed cockpit legal ultralight that looks, acts, feels, flies, and in a lot of respects performs like a real airplane. It does not look like something that emerged from the hang glider movement of the 80s. So I want it to look really nice when it gets done. That's important to me. But so I think I've checked Part 103 compliance off the list. One of the just a few other things feature-wise, you can see that it's got folding wings, and I've set it up here to show off the folding wings. We're going to rotate around the model and have a good look at what it is that we see. You can see that as folded, we've got the flaps and the ailerons flipped up to provide plenty of clearance. As the wings fold back, there has to be a notch, and you can see that here in the fuselage, that allows the bulk of the wings to fold over. When the wings are unfolded, that particular notch is covered with a cover, which we call a turtle deck, and the turtle deck is just reattached with some screws, so it provides a seamless look to the airplane after the wings are unfolded. Process of folding and unfolding the wings should take 5 minutes. In the past, I've done it with my own designs in just a couple of minutes, so it's not hard to do. From the looks of the airplane as well, we want this airplane to look just exactly like a little brother to the Chipper 2. So we end up here with something that I'm calling the Chipper ProCub and the Chipper UltraCub. The difference between the Chipper ProCub and the Chipper UltraCub is going to be just the level of treatment that we provide to the airplane. The Chipper ProCub is going to come with rounded wingtips, and the Chipper UltraCub will have square wingtips. The ProCub will have a little larger span as a result, and a little better better takeoff and landing performance as well. There may be a couple of other cosmetic-y things that I throw into the mix between the UltraCub and the ProCub, but the idea remains the same as it's always been with the UltraCub and the ProCub, that at their core, aerodynamically, they really are the same airplane. The ProCub is more refined. In the past, we put a better turtle deck treatment on the ProCub to make it look more like this, and now both the UltraCub and the ProCub will have the same, what I think are pretty sexy lines for the rear of the fuselage. I've got some other debates that I'm working on internally. One of them is the tail feathers, the method of construction. The easiest method of construction is composite foam with aluminum tubes or angles built into it. Some people object to that. I'm kind of working through that. Alternative is to do it from Honeycomb like I did with Chipper 2. The problem with that is that the cost of goods, the cost factor, just goes through the roof when we do it that way. But so I got stuff to work with there. It can also be done with tubing. It can be done with a welded frame. There's just a lot of ways to get it done. So I have the shape of the vertical and horizontal elements to deal with there, and how to actually actualize them with physical materials. Some other things that are feature-wise, This frame here, everything that you see on the side is basically a Honeycomb rail. You'll know that Honeycomb saved my life when I had that accident up in Alaska in 2018 where the engine quit while I was executing a go-around at Lake Hood. Boy, that's a nasty topic for another time. But in this case here, we've got the Honeycomb, and I've set it up so it's kind of a beam. We've got these Honeycomb inserts that provide the anchor points for the crosses for what goes underneath the seat. And then this whole area on the side is going to get sheeted with aluminum. So basically this is a great big aluminum beam that provides strength and support fore to aft for the pilot in the event that you have a accident where you're moving forward. My hope is that this structure here at the base of the cabin provides forward crush strength for the occupant. A couple of things that are interesting to look at on the design as well are how the upper cabin, not shown here is that there's some bars that transfer thrust from the engine up to the top of the cabin, and it triangulizes this area as well so that we end up with strong supports on this A-pillar region. Then you can see that the loads go back through here and they're transferred back in turn back to the rear of the cabin. The likely thing then is that when they get to the rear of the cabin, the loads are going to get transferred into some sort of likely mandatory aluminum side skin that it goes here and allows all this to be transferred back and forth. So we have loads that are coming up here, through here, flowing back down here, and of course loads that are coming through the bottom as well and flowing back down that way. I haven't put anything in here for control structures yet. I'm thinking of borrowing components from the Chipper 2 that help make it easier to build and a little better quality. We'll see what we do with that. But in any case, this is it. Be sure to support me on Patreon, patreon.com/James Wiebe. You do have to spell it right. So when you get to my Patreon site, Patreon is patreon.com, and James Wiebe, Wiebe is spelled W-I-E-B-E. And so you can get the blueprints for this over time as I continue to develop it for just $10 a month. And also I appreciate support. I've got support levels lower than that and higher than that as well for different kinds of things. In any case, I think that's it for today's chapter of the development of the Chipper UltraCub and ProCub. Have a great Monday.